Good afternoon. Today we're going to just do a little bit of work to finish off chapter 4. We're going to look at section 4.6 today, which is just essentially combining some of our different types of transformations to create what are called similar shapes. So for the first time this year, new definition. We're going to come back to this one later, but for now, similar shapes are going to be shapes. So triangles, rectangles, quadrilaterals, and so on. Shapes with equal angles and proportional sides. Right? So the angles on two triangles, as an example, the angles are going to be equal and the sides are going to be proportional. And what the word proportional means is when we're comparing any of the sides, they're going to be equal to the scale factor. So the scale factor from section 5, so if I take a side AB and compare it to A prime B prime, that is always going to be equal to the scale factor, right? So whether it was an enlargement or a reduction, we always have that scale factor that we multiply everything by. And so our similar shapes will have equal angles and proportional sides. Okay, and we're just going to look at a couple of examples on this video. You'll be able to use the rest of the class period to work on the assignment. It's a really short one, so you should have plenty of time to get it done and over with. So when I come back next week, you'll be able to hand it in on Monday. All right, so what I'm going to start you with is a triangle located at 12, -6, 0, -3, and 3, -9. Those are the 3 points. And then I'm going to ask you to do 2 transformations. We're going to do a reflection about the y-axis. And then we're going to do a dilation using 1/3. Oh, that's a terrible 3. Using 1/3. Okay, so like always, we're going to draw a picture of our original triangle in this case. So I need you to go 12 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and down 6. Stay in the middle, go down 3. And then 3 to the right and 9 down. So 3 to the right and 9 down is right about there. And then when I connect A to B to C and back to where we started, that's the triangle that we're starting with. Now if I choose to do my reflection in red, then I'm going to look for, of course, the new ordered pairs like we always do. And with a y-axis reflection, the y values always stay the same. The y values stay the same. And we take the opposite of the x's. So the opposite of 12, the opposite of 0, the opposite of 3. So the y values stay the same and we take the opposite of the x's. So for my picture to draw the reflection, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so here we go in red. 12 to the left and 6 down is the new location for A. Stay in the middle, go down 3 is the new location for B. Left 3, down 9 is the new location for C. So when I connect A prime, B prime, C prime, and back to where I started, I then have a reflection about the y-axis of our original green triangle. Right? Then I'm going to choose to do the dilation in blue. I'm going to choose to do the dilation in the color blue on your on your laptops. And like usual, I'm going to get the new ordered pairs. And what we have to do here is we have to multiply all of our previous x's and our previous y's by 1/3. Our scale factor is 1/3, so we multiply all of the x's and all of the y's by 1/3. So here we go. -12 times 1/3, -6 times 1/3, 0 times 1/3, -3 times 1/3, -3 times 1/3, -9 times 1/3. And we get all of our new ordered pairs. And of course, once we have the new ordered pairs, now we can draw our dilation. So this is left 4 down 2, the new location for A. Stay in the middle, go down 1 is the new location for B. Left 1 down 3 is the new location for C. So we reconnect the points A double prime, B double prime, C double prime to get that triangle. And what we say at the end is that the original green triangle, so the original green triangle ABC, is going to be similar to the blue, which is going to be triangle A double prime, B double prime, C double prime. And if they're similar to each other, that means they have equal angles and proportional sides. Proportional sides. So if I compared a green side to a blue side, so if I compared a green side like AB to a blue side, A double prime, B double prime, the ratio of those two sides is going to be the same as the scale factor, right? And it doesn't matter if I picked AB or AC or BC, it doesn't matter which sides I pick, as long as I put them together, the ratio is always going to be 1/3. Okay? All right. And we're going to run through one more example. Feel free to pause the video at any point if you need to get some extra things written down. But my second example and last example is going to be for a quadrilateral located at F, 0, 0, G, 3, 0, H, 2, 2, and I, -1, -2. And this time we're going to go crazy and do a 3-part transformation. So the first one, we're going to do a translation. We're going to subtract 3 from all of the x's, add 2 to all of the y's. We're going to do a dilation using 2 for our scale factor. And then we're going to finish this last problem for the chapter with a reflection. And the reflection this time we're going to use is around the x-axis. Okay? So, like usual, we'll start with the original shape, which is a quadrilateral located at 0, 0, 3, 0, 2, come on, pencil, 2, 2, and -1, -2. So -1 and -2. Let's see, did I get those down? 0, 0, 3, 0, 2. Oh, I have a typo, darn it. I have a typo. H was supposed to be 2, -2. H was supposed to be 2 and -2. So let me letter these so you can see them better. So F, G, H, I. And when I do a connect the dot puzzle, you can see then I get my quadrilateral. Okay? Now, going crazy on this one, we're going to do 3 transformations. We're going to do a translation, we're going to do a dilation, and then we're going to do a reflection. Okay, so I'll choose to do the translation in red. So I'll have F prime, G prime, H prime, and I prime. And what we're supposed to do with the translation is we're supposed to subtract 3 from all of the x's. Subtract 3 from all of the x's. So 0 minus 3, 3 minus 3, 2 minus 3, and negative 1 minus 3. And to all of the y values, add 2. To all of the y's, add 2. So for the y values, 0 plus 2, 0 plus 2, negative 2 plus 2, negative 2 plus 2. So our new ordered pairs then are going to be, I just need a few more tick marks for now. Right, I think that's enough. New location for F is 3 to the left and up 2, so 1, 2, 3, up 2 is the new F. The new G is stay in the middle, go up 2. The new H is 1 to the left and 0, so that's the new H. And the new I is 4 to the left, 0, so that would be here. So we connect F prime, G prime, H prime, I prime, and we get our new quadrilateral. Right? Next, we're going to do a dilation using a scale factor of 2. So F double, G double, H double, and I double prime. With a dilation of 2, we multiply all of the x's and all of the y's by 2. All of the x's, all of the y's by 2. So we just go all the way across the reds and multiply by 2. So negative 3 times 2, 2 times 2, 0 times 2, 2 times 2, negative 1 times 2, 0 times 2, negative 4 times 2, and 0 times 2. All right? Alrighty, and let's see, 1, 2, 3, 4, that should be enough tick marks. All right, now I can draw my new picture. So left 6, up 4 is the new position of F. Stay in the middle, go up 4 is the new position of G. Left 2, 0 is the new position for H. And then left 8, 1, 2, 3, 4. Oh, I think I I think F went a little too far. I was supposed to go 6. 1, 2, 3, 4, 5, 6, and 4 up. So F went a little bit too far. So I'll fix that one. And then I is supposed to be the one that goes 8 to the left. So reconnecting F double, G double, H double, I double, back to where we started. That would be our new quadrilateral. And then finally, in purple, we're going to find the new locations after we do a reflection about the x-axis. So when we reflect something about the x-axis, the rule is all of the x's stay the same. So the negative 6 stays the same, 0 stays the same, negative 2 stays the same, negative 8 stays the same. All of the x's stay the same, and we have to take the opposite of the y's. So the opposite of 4, the opposite of 4, the opposite of 0, the opposite of 0. And of course, positive and negative 0 are the same thing, but we can now do the x-axis reflection by going 6 to the left and 4 down is the new location for F. Stay in the middle, go down 4 is the new location for G. Left 2, 0 is the new location for H. And then 8 to the left, 0 is the new location for I. And just reconnecting now gives us our x-axis reflection. Okay, and so we've made 3 transformations, but the key is kind of the last important thing is that the one we started with in green, so quadrilateral F, G, H, I, is then going to be similar to the quadrilateral we ended up with in purple, which would be F triple, G triple, H triple, I triple prime. Those two are going to be similar to each other. So all of their angles would be equal, and all of their sides would be proportional. Okay? All right, so that's the end of the chapter. That's the end of section 6. So now with the remaining time you guys have left in class, go to work on your assignment for both section 6, and you can also, of course, work on the chapter review. All right, so have a good weekend, and then we'll see you on Monday.